Good morning, everyone, once again. Now, thanks for coming that early to listen to us, and today we'd like to speak about scanning. Static scanning of the JavaScript, and in particular in the Dart language and Dart development. We are planning to share with you today the following things. What our application is all about and how do we apply the static scanning approach for the source code and how do we do it on the front end, on the back end. We will discuss the main problems which may exist on the front end. We will give you details of our statistics code analyzer, and we'll look at the results of this work. My name is Dmitry, and now I'm Director for Information Security for the Right company. I've been in information security for 10 years, began my career in development. I was developing different applications on Java, web applications. Hi, my name is Grigory, and I have the similar history to Dmitry. I am involved in security and I'm currently employed by RIKE, and I enjoy it. Well, let's go. Let's see who we are and what we're doing. RIKE is basically the classic three-tier application, which is created from, which consists from the front-end, back-end, and database. Web application where you can find a lot of different inquiries from the front end, a lot of WebSockets, and many other things as well. Moreover, our application, and namely the front-end part of it, consists of JavaScript and all of its variations, classic JavaScript, HEF and TypeGF, and Angular, Dart, and many others. We know that with the appearance of the new framework JavaScript, the old one basically becomes obsolete in a matter of 1 month. So this approach is applicable to us because we always want to be at the front line. Let's consider what are the approaches to analyze source code at the front end and at the back end as well. First of all, this would be the manual review, where you grab a lot, where you are looking, you're using your hands. Second approach would be DAST, dynamic approach, a lot of scanners which enable you in a dynamic mode to analyze web applications. Next would be the SAST, static approach, both commercial solutions and the free source code analyzers. And the last one will be interactive, which is the composition of dynamic and static approaches for analyzing. Like I said before, the manual review, especially at the front end, is a pain. It's incredible pain because you have a lot of front end, different combinations of front end. JavaScript is quite a unique language, and it's difficult to understand what is written. There are a lot of different, even comic books on this topic. Like I, cannot stand JavaScript. And this approach is hard to achieve, hard to implement. As for the dynamical approach, basically it works. Moreover, it works in our case. We have quite a solid approach to analyzing and reviewing front-end part of the JavaScript. And our automation professionals, they're writing quite a lot of tests which are covering our application, and we are reusing them for the safety reasons. It's all integrated in the testing environment, and we also use it in such scanners as burp, VP scanning, different other testings. We have the self-writing tests, and we're also looking at the fast. And all of this is integrated, and we get momentous feedback about zonal vulnerabilities. We set the tasks, and developers are working on these tasks, and so on and on it goes. But unfortunately, it is not all that bright and shiny, as I said. Yes, it's working, but it's not working always. In 100% of cases, due to the nature of our application, we do not have classical inquiries. Like I said, we have a lot of sockets, web sockets, which do not enable one to analyze application in a dynamic mode and do it with the quality. Oftentimes you have to emulate a browser, which calls for additional complexities. And of course, auto tests, they are not unlimitedly extensible. They cannot cover the full functionality of our app. Why don't we consider an SAST approach if the dynamical one is not quite effective? Let's see how the statics will show itself. Why have we decided to look in this way? For many reasons, the main being that our team for quite a long time has been working with a static and source code analyzer, albeit for the backend we have some experience in this field. We have been developing that for our backend part. And moreover, all the statical analysis is based on custom rules. That is, we're always writing custom rules for our analyzer. We're improving them. All these basic rules are grounded in our basic logics of our application, the specific structure of our application, and it works. And moreover, we have quite an interesting approach. That is, we mark models at the backend side. We do classify data, the fields of classes in the following way. We have certain annotations, which are basically the data classification, and we have some fields which are marked as sensitive data, things like authentication data, medical, finance, personal data. It makes sense. Now, customers' data and some of our internal in-house data. So we look at the backend for this data to stay, not to be locked when unnecessary, and looking at the location of this data. This is what it looks like in the code. We have a class, and for each class you have certain annotations. Since we have such a big experience, why don't we use this approach also for the front end, even though it's a JavaScript? Now we also have commercial tools and open source tools to analyze JavaScript, and on an annual basis different companies are holding various research in this field. They are trying to write a statics analyzer which would work for the whole JavaScript in its entirety or for some segments of it. In our front end, we've had it enough with different grabs and just common reviews. We are seeing how the code is just basically increasing. Looking at the team who is working with the JavaScript and taking into consideration that there is basically no instrument to analyze data, we've decided to write our own. But before sitting down and start writing it, we've realized all the possible problems and risks we will not be able to mitigate. But basically, there are not so many problems at the front end. Basically, there are only two issues which we're concerned about. First of all, is a potential leak of data, both customers' data and personal data. And so, what would be the possible leak scenarios in different trackings, which are present at the HTML pages, web pages, and recently the European GDPR is also says that working with the personal data, you have to understand how and where these data will be used. The second issue with the front end is a cross-site scripting. Cross-site scripting, everybody knows about it. What the problem is about the personal data disclosure or different data disclosure at the front end side. That is, you have tracking analytics, which may be both internal for your team and also external. Yandex, Metro, Google Analytics, and Facebook and Twitter are all included. And the problem is that the analysts have access to the admin panels of the Google Analytics, and they may change it in such a way that it may result in disclosing personal data or internal data in your app, and we would like to avoid that as much as possible. And we also have the problem with the regression testing. It's very difficult to cover all these regressions and the tracking sites. They appear, they disappear, they reappear again, and it looks somewhat like that. We have, let's say, the password rebuilt in page, and the client comes, click on it, and we would not want this token to leak to a different site and to be logged in, even for our internal analytics. As for the cross-site scripting, problems are somewhat the same. Everybody knows this problem very well. When on the side of the JavaScript there is an execution of the JavaScript in the browser of the victim, and the problem is the same. You cannot cover your regression, dynamic is not very good, even if you work in the manual regime, it's very difficult, and also different components, like we said, the frameworks, ones and others, this JavaScript and that JavaScript, it's a classical thing. Somebody is inputting something in the app, and this has been worked out in the victim's browser. Having thought about these problems, we decided to write our own code analyzer, which would help us to deal with these two reasons, with these two problems. Hi everyone, again, and today we would like to speak about a theory, a little bit of how all this is working. You have here a statics analyzer, and you have to have a certain internal rendering for it to analyze what is it and what the analyzer is working with. And having built or building this internal model is built on a certain components. The first being the data model itself, and this will be the secondly our repository. Again, there are certain classes, there are certain fields, and we will be speaking about that. The second thing is the AST tree. This is the tree where the internal peaks are corresponding to operators and the leaves to operands. This enables you to understand what kind of lexemes you have in this language, what it all looks like, and have a general idea about your code. And next, you have to build the graph control the execution so that you could track and trace all the links of how your program can go, and also the challenges game, which enables you to or calling game to go from one call to the different call and to analyze. Let's go into detail about the AST and to speak about it. This is the very simple example. You have simple if, and you have a certain if else, and you have the offer. Your AST tree will be looking in the following way. Here we have certain condition, precondition, then what do we do if it's a true, and then we have the call for the method. But again, it's not only relevant for this part, but also for the whole JavaScript. There have been different parsers for the TypeScript at the node. For the Angular, there is also AST parser, and probably you won't have to do it yourself. It's all been already written for you. And also another good thing would be dependencies, because as you know, in the Python, in Node, you may have different managers, packages like a PIP or npm in the node, and you will always be able to pull up different dependencies. As Dmitry has been speaking before, in components there could be many problems, and we also have to be able to trace them, because again, especially for Dart, there are no like special researchers looking for vulnerabilities like let's go into using checker. There are some problems, so we want to do it on our own, and to this end we have pub-get, you show what kind of dependencies you need, you call for this pub, it comes up and then shows you where all these packages will be stored. It's all stored in the open source, and we can, in the same way, not only to scan our code, but also all the components which are being called and used in there. Parsing of the AST tree will be looking in the following way. Let's focus on the things which are very important when you do this. Number one, do not forget about imports, because this could be the imports of your SDK. You probably might need to go in there or call in some customized imports, both your libraries and different components. Next, it's important not to forget about the different transit imports. If you have a library which encapsulates different clients, and you are connecting and connecting and connecting again, and this is also very important to do it on the Dart AST parsing, so that you would know where to look further. And then the very simple structure, this would be the beginning of the scanner. Or scanner visitor. You use parent visitor to be able to get in there and to see each node from your AST tree, and to make a decision what to do with it. You need to do this, or you need to do something else. And also, it's important to understand that for your analyzer, if you'll be doing something yourself, you have to have a real good understanding of how your code is functioning, like how things are happening in the code. Like, since we have the Dart app working with Angular, it's important not only to dig into the Dart code, we need to know what is going on in Angular. We can do that because our Dart is based on components, and each component has a certain Angular template, and in each component there is a direct link to this very template. And you can just use this link, take an HTML of this template, and also to parse it by the Angular parser. And the parser, when it sees the import of a certain component, it will go to the right HTML, will do the parsing, and then for the Angular, you will be using exactly the same approach with visitors. You'll be going through each node and make a decision what to do with it. Let's keep talking about the implementation of the scan. It's based on the rendering of internal model. Well, it's an execution graph and a call graph. And to this end, we are always looking at the context where you'll be storing information for your class, meta information, and many things. In our case, we're using two of them. Number one will be a global context, where with our markings we put in some information, and a local context. This will be like a certain method of yours, the local variable, and you attribute something to it. And this local context will be existing within your method. To give an example, this is what the flowchart of this code would look like. It's a graph, it's a workflow graph, and this looks like that. You have your if, in one case you do this, in the other case you do something else, and then your flow is split into two different chains, unrelated chains. And for us to be able to track it, whenever we see the expression, we have to do two visitors who will get some local context from the previous implementations, and after working out with this visitor into which we've placed the local context, based on these results we update our context which had been called before. And in the code, it will be looking somewhat like that, when we can see the node with if, and this branch will implement it in the code with two different visitors. And also the call graph, basically the call graph will be just a node of the visitor with the empty context, because it does not need a context, but some information about parameters which we handed over, as well as a global context. It works, and then you keep working with the local context where you have a call. And in the code, it's looking somewhat like that. The most important thing is, if you're seeing the method call, is to build a right mapping so that you'll be able to see its body and to go through it. There are different aspects with heritage. You have to take it into account. But in addition to the obvious calls, there are some calls which are not very obvious. Please don't forget about them. In connection with the Angular, in your Angular code, you can also have a call for certain methods. For example, this is an example of a component. Get usernames by all these, and you have to build a mapping between your Angular and your Dart code, and to understand what is happening even in this Angular structure. In addition to that, I want to go back to this one. It's a little bit closer to this example of when you have in a Java code, you have an over two-string method call. It's not obvious, but when you do the plus and you do this kind of string, then you can see the obvious call. You have to remember about that. Also, in addition to the call from the Angular code, you have such a component as including one component into another. It is happening oftentimes when you include some other components. In your Angular code, you tag the name of a component, and then your Angulator is looking for what kind of components are available, find an array selector, and basically like switching on or including one component into the other. It's like a method call, because each component has its own life cycle. And like any call method, you also have a parameters which very obviously in an overt way using annotations you can also put it in there. There's another not very obvious way. It's a pipe. You'll have your Angular code, you'll have the symbol of a pipe and some name. Interpreter will will look for a pipe with this name and will call transform methods. We've taken some value, applied pipe, and we get not just some value, but some value test, as you can see in the right bottom screen. And this is also something to remember about because it's very specific to Angular. Basically, in all Angular implementations, you can see this. And we come to conclusion that all that we've been speaking about is important to implement in it's very simple in terms of connection with the AST tree. You simply have to go deep along the AST tree, implementing those preconditions about the context and visitors which we have been speaking about. Would like to give you some example. Again, this is the code, and when you go along your AST tree, you go deep to the left branch of the tree. And this is what it's going to be looking like if you compare it with what we've been saying about. This is the rendering. You will see exactly the same thing. Let's go to the right branch now, and we are getting the same thing. Our solution has made its way to the left, to the right, and we got our expected result. And the third time, when it's gone through these two branches, we go upward. We pass the information that we have the if and else, so we have to do it 2 times with previous results with different local context. And this will be looking in one case like that. In the other case, it will be simply a calling for a different method, but in whatever case, we are going to continue method for one branch and to continue method for the other branch. Now we've been speaking about the internal rendering. Let's speak about analysis of how it's all going to look like. Yeah, and you analyzed, it's like a tainted flag, some input which you do not fully trust, or certain metrics that you have a certain type of data, and this data, according to the flow, it's flowing from one data to the other variables to the methods. It's like spreading all over, and by doing this, marking other variables and other things, and also marking with these tainted flags, and then this data ends up, in our case, we can mark them with annotations. We have a class user, and we say that its name is a personal data. But except for the code, because the code is done by the developers, we cannot guarantee that they will be always be doing the markings, they will never forget it. We also have to control it ourselves. And for this, we also help with the configuration of our scanner. We can say, okay, this is the data which will be in the class, or which will be having some user, and some fields are about the personal data, some users' personal data. And after we've done all the marking, all the flow, in all the variables, we need to make sure to get a sink. Sink is basically the place when certain data ends up in a sink, there'll be a flag that, okay, it's a vulnerability. Also, with annotations, we can mark these things. Okay, this method is actually async, not only in a code, like we are showing right now, but also in config. We're showing what kind of flags which would be not permissible for this method, and in this way we do our description. And now let's go to some examples, and we'll show you how it looks in the real life, what kind of chains, what kind of sequences we can see. And let's begin with the tracking. Okay, here you have certain method add. We have the local variable. We put the full user name, and then what the scanner is doing, it sees this field and looking at the global context, and then finding that this data is marked by the tainted flag. It's a personal data. Okay, we remember that. And then it keeps going along the flow and sees that we have the variable, and in the local context it marks that, okay, with this tainted flag, this variable is also contains this tainted flag. Okay, we keep going. Then there is a call for certain methods, and we remember that in our local context, 2 times we've noted out that this personal data is with a tainted flag, and then we call for a method, and in the global context again it remembers, okay, it's a sync. So we get a problem because because data with the data flag ended up in sync, which is bad. And after that, we get certain result. Okay, guys, you have to look into this location in a code, in this code segment. Most likely there is a problem in this code. Now, XSS. Many people have been speaking and will be speaking about the XSS. For the Angular, they're quite specific because by default, usually there is a scripting, but you can always shoot yourself in the foot, so to speak, to call these methods, and it will be alleviated. These are all the methods of how you can do this, which in the terminology of the sync and data flag, what XSS will be looking like. We have a certain user's code. How can we use it with our annotation? We simply combine multiples of all this sensitive data, because either way we are getting them, this data from the user. And the second condition, the second flag, will be calling of this so-called unescape. What will be the sync in this scenario? We have two types of syncs. One would be Angular, and these are all possible locations where this data may fall into XSS. And also in the dark code, we also have different locations. How the scanner will be working when it will be checking all of this? In our Angular page, the scanner will see a certain item, and first it will not understand what this item is about. So you have to look up in the Angular what item is. Okay, so we have a cycle. This is the cycle, and it iterates certain objects of items. Let's see then what items is. Okay, items are here in the dark code. And the system will say, okay, it's a certain list with a user class. So when in this location we're calling item for name, full name, we take in certain user and calling a full name of that user. In our terminology, data flag, it means that it remembers configured file, where we say that the data which lies in this class, in this kind of classes with this kind of names, will be actually a personal data. Hence, we have the very first flag. Let's keep going. It says, okay, we have a certain pipe. What kind of pipe? Oh, this is the pipe in the code. And then immediately looking at the transform method, because it can see how the flow with pipes will be looking like. And this is, it goes a bypass security HTML, and we get the second flag. So we have already two flags assembled. Now we have to look into this very sync. But our syncs have been described. We've listed all of them. We have all the means of how you can do that. And so we have built into our analyzer understanding of what kind of syncs in XSS. And here we have an issue. And after that, after finding a problem, we get a certain alerting. Okay, guys, you have to look into that. Probably there's an issue with your XSS. Let's make a summary. What do we have? What is our result? We've learned how to find certain vulnerabilities which we failed to identify before because they had been too many. We didn't have time to or chance to find them. And with testing, we also didn't cover all the cases. So statics helped us. In regression, it's also a big help because we have a certain set of old bugs with a certain probability may reappear in the system, in the code. And so having learned our scanner to find all the older vulnerabilities, we guarantee that in case guys will return this bug, we will find this bug, we'll track it in the system. Also, we have several ways of how to control these very trusted inputs. Number one would be the developers are marking that, and we can help them. Config analyzer, which is also working by the graph, but you cannot make it in a static regime. And also we have the additional utilities which are based on the AST tree, enabling us, first of all, to understand what data are being stored in a particular front-end app, and also to control, make sure that developers will not forget to mark certain things. Another benefit is customization. Unlike many things you buy, many products you buy, if for whatever reason you cannot make a certain rule, it's impossible to make this rule, then you will have to go into scanner. You have to say, guys, you have to finish up the functionality. It's not a fact that they'll be doing it. In our case, we always take, we see the problem, and we go and fix this problem. It's very convenient. We do not have very high false positive rate, about 10% for tracking, which is basically okay with false positives, and about 40% with XSS. Yeah, it looks like 40% is a lot, but it's not actually a lot. It is not like a gigantic number like hundreds or thousands. We're speaking about dozens. And to to work with this kind of quantity is not a big problem. Speaking about advantages, low cost. We've used literally a couple months for the development, and this is very good because we've spent less time for development than if we would spend on the manual reviews of the code and never ending running back and front to this code with these tasks. And also, the support does not take much many resources, because we find some things, false negatives, and we simply have a specific case. We need just to adjust it case by case. These are the very good links for you to study. It's an parser for AST parser for Angular, AST parser for Dart, and a little bit of theory for statistical analysis. And I think we are done with this, and